A supernova is a powerful and luminous explosion of a star. A supernova occurs during the last evolutionary stages of a massive star, or when a white dwarf is triggered into runaway nuclear fission. Okay, so a lot to unpack. Stellar evolution is its own thing entirely. Stars evolve, apparently. And a massive star is different from a star, although it looks like it's linking me to the same wiki. And then there's a white dwarf, which is its own thing entirely. So it's an explosion, a luminous, which means I think a lot of light, full or shedding light, right? So a luminous explosion of a star, and it's the last evolutionary stage, but it can also happen when a white dwarf is triggered into runaway nuclear fission, whatever that means. Okay, the original object called the progenitor either collapses into a neutron star or a black hole. Two other things which I vaguely know what they mean. Neutron star, I don't know. Black hole, I've heard of. These are places with very strong gravity where nothing escapes them. I don't understand how they collapse, but they do. Okay, let's keep the sentence going from the beginning, because I digress. So the original object called the progenitor either collapses into a neutron star or a black hole, or is completely destroyed to form a diffuse nebula, which is a particular kind of nebula, it seems. The peak optical luminosity of a supernova can be comparable to that of an entire galaxy before fading over several weeks or months, so it seems like it's a metaphorical flash in the pan, but it's super effing bright, very bright, as bright as an entire galaxy. That's amazing. But it's a flash in the pan, and it's an explosion, and it is the last stage, it seems. So like stars explode into supernovas, or white dwarfs go to runaway nuclear fission. The last supernova directly observed in the Milky Way. Oh, by the way, let's take a look at this picture. This is, I don't know, I think that's a name of a galaxy. So SN9, 1994D, the bright spot in the lower left, a type La Supernova within its host galaxy. Look at that. It is comparable. Also, another kind of question is, why is the center so bright? Why? Is it because of the density of stars? Cool question. I wonder if I can, maybe we'll get to that maybe we'll answer that on the Galaxy Wikipedia. But why the center is so bright. Anyways, the last supernova directly observed in the Milky Way was Kepler's supernova in 1604, appearing not long after Tycho's supernova in 1572. So this is at the end of the Middle Ages, beginning of the modern era. Kepler, I guess Johannes Kepler observed it, perhaps. And Tycho Brahe, we learned about him, or we mentioned him during the scientific revolution. He was, don't forget his country of origin, but a prominent scientist, fledgling scientist in the beginning of the scientific revolution. Both of which were visible to the naked eye. I would assume so. Because they are luminous. The remnants of more recent supernovae have been found and observed, and observations of supernova in other galaxies suggest they occur in the Milky Way on average about 3 times every century. A supernova in the Milky Way would almost certainly be observable through modern astronomical telescopes. The most recent naked eye supernova was SN 1987A. I am kind of curious how they like what does SN mean and what do the numbers mean and how they catalog these names, but let's continue. The most recent naked eye supernova was this one, which was the explosion of a blue supergiant star, which is its own thing, its own Wikipedia, in the large Magellanic Cloud, a satellite galaxy of the Milky Way. The theoretical studies indicate that most supernovae are triggered by one of the two basic mechanisms. Okay, so we talked about this in the first paragraph. The sudden reignition of nuclear fusion in a white dwarf, or the sudden gravitational collapse of a massive star's core. In the reignition of a white dwarf, the object's temperature is raised enough to trigger runaway nuclear fission, completely disrupting the star. Possible causes are an accumulation of material from a binary companion, which is its own thing, through accretion, or by a stellar merger, which I don't know what that is. In the case of a massive star's sudden implosion, the core of a massive star will undergo sudden collapse once it is unable to produce sufficient energy from fusion to counteract the star's own gravity. One more time. In the case of a massive star's sudden implosion, the opposite of explosion. Yeah, something collapses. The core of a massive star will undergo sudden collapse once it is unable to produce sufficient energy from fusion. Interesting. I guess the fusion somehow keeps the star stable from not collapsing. And the second it cannot maintain fusion, that's when implosion happens. Yeah, there it is. Unable to produce sufficient energy from fusion to counteract the star's own gravity, which must happen once the star begins fusing iron, but may happen during the early stage of metal fusion. Interesting. So supernovae can expel several solar masses of material. That's a lot. At speeds up to several percent of the speed of light. Looks like a cool article. This drives an expanding shock wave into the surrounding interstellar medium, sweeping up an expanding shell of gas and dust, observed as a supernova remnant. Supernovae are a major source of elements in the interstellar medium, from oxygen to rubidium. The expanding shock waves of supernovae can trigger the formation of new stars. Supernovae are a major source of cosmic rays. They might also produce gravitational waves. Okay, this is the Crab Nebula, associated with... Okay, there's a lot written about it, but how cool is that? How cool looking is that? Jeez. Supernova remnant. Wow. Look at that. Unbelievable. A light curve for type. Oh, okay. This is like how the luminosity fades over time. Look at that. Wow. So there's different types. Of course, I'm not going to get into this entire Wikipedia. That would be insane and take a long time. I wish I had the time, but that was, yeah, you guys should check out this if you're interested. It looks like a good one. The progenitor we learned is like the whatever, like the source, I think. So it can happen all kinds of different ways. Okay. All right, that's it for this one.